Today I am talking about the 2017 June CSIR NET question paper. In this question, two long hollow coaxial conducting cylinders of radius R1 and R2 are placed in vacuum as shown in figure. Here R1 is less than R2. The inner cylinder carries a charge plus lambda per unit length and the outer cylinder carries a charge minus lambda per unit length. So the electrostatic energy per unit length of this system is what? So the electrostatic energy in hollow region of the conductor, we can write it as the electrostatic energy in hollow region of the conductor is U equals to capital U is equal to integration over half of epsilon 0 E square d tau. Here this is the energy for the electric field. This is the half epsilon 0 E square and d tau is the volume element. So the constant term half of epsilon 0 is taken out from the integration, and the integration is from 2r1 to 2r2. Here from the figure, the limit of the integration is 2r1 to 2r2, and here lambda is the charge per unit length. So here lambda is the charge per unit length, so we written as this lambda divided by 2 pi epsilon 0 r. As the permittivity of the vacuum is epsilon 0, so we can written as this lambda divided by 2 pi epsilon 0 r into this volume element is 2 pi r dr into L. This is the volume element, 2 pi r dr into L. L is the length. Then we can write this, the energy U divided by L is equal to lambda square divided by 4 pi epsilon 0 integration over 2r1 to 2r2 into 1 by r dr. Here this is the lambda by 2 pi epsilon 0 r square, as this is E square. So this is lambda by 2 pi epsilon 0 r square into 2 pi r dr into length. So if we calculate the integration, this equal to lambda square divided by 4 pi epsilon 0, this is the constant term, and here dr by r is equal to log r. So if we put the limits, so log of 2r2 divided by 2r1, then this energy per unit length is equal to lambda square by 4 pi epsilon 0 log of R2 by R1. So the electrostatic energy per unit length is equal to this. So the correct answer for this question is C. C C is the correct option. Here R2 is the radii of the outer cylinder and R1 is the radii of the inner cylinder. So the energy, this is the energy per unit length. Energy per unit length is depending on the radius of the outer cylinder and radius of the inner cylinder and the charge density. So if you have any query regarding this question, you can WhatsApp us or contact us in this number. This is 9836793076. You can WhatsApp us in this number. This is 9836793076. So that's all for today.